Okay, so what I want to review today is analytic geometry. So okay, so the first thing that I want to review is what we call the rectangular coordinates. So rectangular coordinate system is a way for us to describe points in the plane. So what do we do to describe points in the plane? Well, we take two real number lines. So we take one horizontal real number line, and then we also take a vertical real number line, and we call the horizontal one the x-axis, the vertical one y-axis, and they intersect at the point 0. Okay, so the point that represents 0 on the number line, that's where they intersect. So so if I take a point, let's say I take this point here, and let me call that point P. What are the rectangular coordinates of P? Well, I look at the distance from P from the axis, right? So here's one distance. So if let's say x is the distance from the y-axis, lowercase x, and the lowercase y is the distance from the point P to from the x-axis. Okay, distance from P to x-axis. And so the coordinates of P are given by x and y. Let me say that again. X is the distance from the y-axis. Y is the distance from the x-axis. Right. So those are the coordinates of P. Is everybody clear? So that's how we describe points in the plane, by using rectangular coordinates. Any questions on that? Okay. The next thing is the distance formula. Distance formula. Well, again, let's say that I have the xy plane, and let's pick 2 points. So let's call one of the points, let's say that this point has coordinates x1, y1. And let's pick another point and let's say this point has coordinates x2, y2. And so the question is, what's the distance between these 2 points? Well, the distance d between, actually, let me call this point P. This point is, let's say, Q. And so distance between P and Q, I'm going to use the notation PQ with a bar. It means it's the length of the line segment joining P and Q. And so what is that length? What's the formula for this distance? Yeah, so what you're trying to say, I think, is you take the difference between the first coordinates and you square that, plus the difference between the second coordinates, and you square them. It doesn't matter whether I have x1 minus x2 or x2 minus x1, because you're taking the square, so it doesn't matter in which order you write x1 and x2. Am I making sense? So that's the distance formula. Okay. The next thing is slope of a straight line. So what do we mean by slope? Again, let me pick my favorite x-axis and y-axis. So here's my x-axis, here's my y-axis. The reason I have one-sided arrows, because what I mean is that the side indicated by the arrow is the positive side of that axis, right? Okay, so let's say I have a straight line which looks like this, and the question is, what's the slope of this straight line? Well, pick any 2 points on the line. So I'm going to pick any 2 points arbitrarily, and then look at the following. So from this point, so what I did is, from the point P, let's say the point P has coordinates x1 and y1, and the other point is Q, has coordinates x2, y2. And what I did is, from the point P, I drew a horizontal line. From the point Q, I drew a vertical line, and they intersect at this point here, and making a right triangle, right? And the slope is given by the length of the vertical segment, right? Vertical side of the triangle divided by the horizontal side of the triangle. Okay, so that's what the slope is. But can someone tell me what is the length of this vertical segment? What is that length? Exactly, because what's the height of that? Oops. What's the height of that point? Point, that's y2, right? And what's the height of the point P? That's y1, right? So y2 minus y1 is exactly the height, is exactly the length of this segment. What is the length of the horizontal segment? x2 minus x1. Once again, if I look at from the origin, the distance from the horizontal distance from the origin to the point Q is x2, and the horizontal distance from the origin to the point P is x1. So obviously, if I take x2 minus x1, I get the length of that segment. And I think you were probably told that y2 minus y1 is called the rise, and x2 minus x1 is called the run. So the slope usually denoted by m is defined to be rise over run. So y2 minus y1 over x2 minus x1. Here, order matters, right? If you write y1 minus y2 instead on the numerator, then what do you have to write in the numerator, denominator? Yeah, you have to be careful with the order. Okay, so that's the slope of the line. And when will this slope be 0? When the line is horizontal, like when y2 minus y1 is 0, which would mean that it's a horizontal line, right? Yes. Okay. Now, equations of formulas for writing down the equations of straight lines. So one of the formulas that you must have seen is called the slope intercept formula. So what is this slope intercept formula? Well, let's say again I have my xy plane, and let's say that I have a straight line, and let's say the straight line intersects the y-axis at height b. Okay, so b is the y-intercept, right? B is the y-intercept. Or what are the coordinates of this point? The first coordinate is 0, right? So this point is 0, comma b, basically. So the y-intercept is b, and let's say you are given that the slope of this line, let's say you are given that the slope of this line is m, okay? So you're given that the slope is m, and you are given that the y-intercept is b. Then what's the equation of this straight line? The equation of this straight line is given by what? Y is mx plus b. Now, can someone describe to me what does it mean when we say that the equation of this line is this? What does it mean? Yeah, but I'm saying, so I think you are trying to say what I want to hear, which is, yeah. No. So what I want to say is the following. First of all, whenever you have an equation, right, what does it mean to say that the point, let me use red color here. What does it mean to say that the point 1, 2 satisfies this equation? If I say the point 1, 2 satisfies the equation y is mx plus b, what does it mean? Yeah. No, yeah.
That point falls in that equation.
Yeah, the point satisfies the equation, which means that when you replace x by 1, y by 2, both sides are equal, right? So when I say the point 1, 2 satisfies the equation, it means that when you replace x by 1, y by 2, you get a true equation, right? So to say that the equation of this line is y is mx plus b, it means that every single point on the line satisfies the equation, right? Every single point. So if you plug in the coordinates for each point in this equation, you're going to get a true equation. Am I making sense? So pick any point on the line, let's say this point, and plug in let's say this point has coordinates x0, comma y0. If you plug in the coordinates of any point on the line in this equation, you get a true equation. Okay? So again, it means that every point on the line satisfies the equation. All right. That's not the only formula that you have seen before. What's the name for the other formula for a line? Was that? No. Point slope. Someone said point slope. Yes. Point slope formula. So what is the point slope formula? Well, again, let's say I have the xy plane, And let's say I have a straight line which looks like this. And let's say this line has a slope m, and we are given that this line goes through a given point. So this we are given x0 and y0. So we want to write down the equation of the straight line with slope m going through the point x0, y0. So what is the formula? Yeah, so your x1, y1 means my x0, y0, right? So you take y minus y0, right, is equal to the slope multiplied with x minus x0. In fact, if you know this formula, you don't have to know the other one, right? The reason is when you are given the intercept, right? In order to use the previous formula, what do you need to know? You need to know the slope, you need to know the intercept. But if you're given the intercept, you're basically given a point on the line, right? So you can actually use the other formula to write down the equation. So if you want to know only one formula, you don't want to memorize both of them. Well, the second one is the one that you want to memorize. Again, I'm going to give you I'll be giving you an example in a bit. I'm just writing down all the facts from analytic geometry, and then we'll go over some examples. The next thing that you need to remember is the facts about parallel lines. Again, if you have two straight lines that are parallel, what can you say about their slopes? They are the same. Very good. So if I have another one, so let's say this one is line 1, this one is line 2, this one has slope m1, this one has slope m2, then what we know is that the slopes are the same. Everybody's okay? So two parallel lines will have the same slope. Okay, so how about perpendicular lines? Suppose I have, so let's take one straight line which looks like this, and the other one, let's say so these two are perpendicular lines, and let me call this one L1, this one L2. This one has slope M2, this one has slope M1. What can you say about M1 and M2? Yes. Very good. So what he's saying is that M2 is -1 over M1, right? Is everybody okay with that? Or you can say M1 times M2 is equal to -1. So this is for perpendicular lines. Okay. The next thing that I want to remind you is the following. How do you write down the equation of a circle? So let's say I have my x-axis, my y-axis, and let's take a circle. Oh, that's a bad way of making a circle. You know what? I'm just going to make a circle first, and then I'm going to make my axis. better. Okay, so let's say this is the origin, the radius of the circle is r. So I want to write down the equation of the circle of radius r centered at the origin. So what is that? Anybody? What's that? What's the equation of this circle? Circle. Equation of the circle. Yeah. I'm looking for the equation of the circle. Yeah. Your 2 pi r is the parameter of the circle, right? Yeah. Did you want to say? Did you have an answer? Okay. Yeah. Go ahead.
X squared over x over r squared plus y over r squared equals 1, or something similar to that.
Yeah. So basically, what you're what you're trying to basically say is that x squared plus y squared is r squared. You don't have to divide out by r squared. I think that what you did is you divided out by r squared. So the equation of this circle, so the equation of the circle of radius r centered at the origin is x squared plus y squared is r squared. Okay, how about when I change the center? So center, what if the center is not at the origin? What's the equation then? So once again, let's say I have a circle and let's say I have a circle, but the center is at a different point. Okay, let's say the center here is given by h and k. So h and k are the coordinates of the center, and the radius is given by r. Okay, so what's the equation of this circle? What's the equation of this circle? Yeah.
X minus h squared plus y minus k squared equals.
Yeah, x minus h squared plus y minus k squared is equal to r squared. So that's the equation of a circle of radius r centered at the point hk. Everybody's okay? All right. So those are all the facts that I think you need to remember. What I want to do now is go over one big example using this facts. So first of all, let's do an example with straight line. The question is find the equation of the line that passes through the point 2, -5, and so I'm going to go over a bunch of parts now. Each question will use this first statement. So and has slope -3. So what's the equation of the straight line passing through the point 2, -5, having slope -3? Well, what's the answer? What's the equation? Yeah, go ahead. What? So you can basically say slope is given, right? So the slope intercept formula is, well, not the slope intercept formula, I'm sorry. Point slope formula. So you take y minus -5, and then this is equal to the slope times x minus 2. So you subtract the second coordinate from y, you subtract the first coordinate from x, and you also multiply the right-hand side by the slope. So that's what you get. Of course, since it looks a little bad, let's make it a little bit prettier. This would be negative 3x plus 6, and so y would be negative 3x plus what? 1. Okay. So that's the first question. So let's look at another question. Let's say you want to find the equation of the straight line going through the same point, but this time it is parallel to the line, parallel to the x-axis. Parallel to the x-axis. So again, the question is, find the equation of the straight line going through the point 2, negative 5, and it is parallel to the x-axis. Okay, yeah.
Y equals negative 5.
Yes, because again, the point is that if you have the x-axis here and the y-axis here, and let's say the point 2, negative 5 is right here, and we are speaking about the straight line which looks like this. So this is the point 2, negative 5, and so the equation of the horizontal line going through this point, right, it's got to be y is negative 5. Because every single point on this horizontal line has second coordinate negative 5, right? So what's the graph of the equation y equals to negative 5? The graph of the equation y is negative 5 is the collection of all points whose second coordinate is negative 5, right? So that's exactly the line. Am I making sense? Okay. That was 2. Number 3, and is parallel to y-axis. What did you say now? Yeah, now what you have is a vertical line at 2, negative 5, right? So what you have now is a I'm going to cheat here. I'm going to say this. So the vertical line it has equation x equals to 2. Again, every single point on the vertical line has first coordinate 2. X equals to 2. The graph of that is the collection of all points whose first coordinate is exactly 2. Okay. Okay. So that's this. That was 3. 4 is parallel to the line given by 2x minus 4y. 2x minus 4y equals to 3. Okay, how do I do it now? Again, the question is, find the equation of the line going to the point 2, negative 5, having and parallel to this line. Okay. Now, again, I know a point on the line I know a point on the desired line. All I need to know is the slope of the line, and I know that the line is parallel to this line, so the slope is equal to the slope of this line. Now the question is, how do I find the slope of this line? Anyone remembers how to find the slope of this straight line? Yeah, yes. You mean yes, slope intercept form. Yes. So that means you solve for y, right? So what you're going to get is negative 4y is negative 2x plus 3. So what we did is subtracted 2x from both sides, and then you divide by negative 4. If you do that, do I get half x minus 3/4? You agree with that? So then the coefficient of x, that's the slope, okay, of the line. And our desired line is parallel to this one, so the slope of the desired one is also half. So all I have to do is use the point slope formula now to write down the equation, right? So from y, I subtract the y coordinate, which is -5, and the slope will be multiplied with x minus 2, right? Everybody is okay with that? Now, how about I change the question a little bit? Instead of saying parallel, I say perpendicular to the same line. So now what do? Yeah, now again I have to know the slope of this line, so I solve for y, which we have already done, half x minus 3/4, and then we know that the slope of the desired line is what? Slope of the desired line will be the negative reciprocal of this one, which is half, so it's the reciprocal of that is 2 and negative of that is -2. And so again, the point slope formula will tell us that it is y minus -5 is the slope times x minus 2, and you can simplify that. Okay, everybody remembers this type of stuff from before? Okay. One more thing that I want to do is that one more example using the effects for circles. Suppose that I have this equation, x squared plus 2x plus y squared minus 4y equals to let's say 3. Okay. And let's say you are told that this equation is the equation of a circle. So this is an equation of a circle, and let's say your job is to find one, the radius, and 2, the center. How would you find the radius and the center if you are given the equation of the circle? Yes. So what do I have to do? I don't have the correct form, right? So I have to put it in that form. And how do I do that? You complete the square, right? So basically, I have to complete the square for x, and I also have to complete the square for y. Remember how we did that a couple of days ago? How did we do that? Well, in order to complete the square for the variable x, you take the middle term 2x, look at the coefficient is 2, take half of that, 1, square of that, 1. So you add that on both sides, okay? Do the same thing for y. Coefficient of y is 4. I mean, it's -4, but let me say 4. And then half of that is 2. Square of that is 4. So you add 4 on both sides. Is that making sense? Now, all you have to do is factor out these three terms and factor out these three terms. If you factor out x squared plus 2x plus 1, what do you get? You get x plus 1 times x plus 1, right? Which is x plus 1 squared. And when you factor out y squared minus 4y plus 4, you would be getting y minus 2 times y minus 2, which is this, and that is equal to 8. And now I could tell you the following. What's the radius? And 8 is what? Root of 8 squared. So the radius is root of 8. Okay, that was the hard part. So what's the center? Very good. Negative 1, 2. It's not 1. It's not 1 and 2, right? It's negative 1 and 2. Negative 1 and 2. Does everybody realize that? Instead of having x plus 1, if I had x minus 1, then the center would be 1, 2, right? But if I had x plus 1, then it would be negative 1, 2. You guys are okay with that? Okay. Any questions on that? Yeah. Go ahead. Radius, on the right hand side you have the constant, right? The square root of that is the radius. Right? Because remember the equation of the circle where is the circle? Yeah. Equation of the circle centered at HK is given by this. And the right hand side is the radius, square of the radius. Okay. Anybody has any questions? What I want to do next is review functions, and I look at the time that I don't have much time left, but I'll start a little bit.
Do you have questions about the review?
Can you ask questions from the review? Yes, you may. Why don't you? If you have any, why don't you ask me now?
How do you factor a third degree polynomial?
How do you factor a third degree polynomial? You have an example in front of you. What you have to do is, first of all, you have to find a root of that polynomial by plugging in numbers. 0, 1, So here's so again, I'm not going into functions right now, just answering a question. This is question number 68 from the review of algebra, and the question has the equation x cubed plus 3x squared plus x minus 1, and this is equal to 0. Okay, so one way to do it is that what you have to do is find a root of this equation first. How do you do that? By force. By that I mean you plug in 0, plus or minus 1, plus or minus 2, until you find a value of x which will make the left hand side 0. Okay. So what if I plug in 0 for x? I get negative 1, right? If I plug in 1 for x, what do I get? Do I get 0? No. What if I plug in negative 1 for x? What do I get? I'm going to get a negative 1 here, negative 1 here, positive 3 here. Do I get 0? Yeah. So notice that when I plug in, okay, so if x is -1, then x cubed plus 3x squared plus x minus 1 does become 0, right? And so what that tells you is that this is a root of this equation, which means that when that happens, x cubed plus 3x squared plus x minus 1, you can write this as x. From x you're going to subtract the root that you found, which would be x minus minus 1, right? Which would be what? X plus 1. So what happens is that you can factor out this polynomial as x plus 1 times something. That something, it will be a what? Quadratic, right? Because it's a cubic polynomial. You're going to have a quadratic here, right? You're going to have a quadratic polynomial. Once you have a quadratic there, you know how to factor that out, right? The question is, how do you get that? First of all, everybody is clear so far? You plug in numbers until you get a root of that polynomial. Once you get one, x minus that would be a factor of that polynomial. So you can write the polynomial as that linear factor multiplied with something quadratic. Once you find the quadratic, you know how to factor it out. Now the question is, how do I find the quadratic polynomial? Anyone? Long division. Very good. I would be so sad if no one answered that question. Okay, so x cubed plus 3x squared plus x minus 1. This was probably you learned way back in 6th grade, 7th grade. I don't remember when they taught this nowadays. So well, I have to match x cubed, right? So what do I multiply the divisor with? X squared, right? So I get x cubed plus x squared. And then what do? Subtract, I get 2x squared and plus x minus 1. Now I have to match what? 2x squared, so I get 2x. And I get 2x squared plus 2x. And then I subtract. Now when I subtract, what do I get? Negative x. Finally, I multiply with -1. I get negative x, -1. The remainder is 0, right? So what we have is that our dividend x cubed plus 3x squared plus x minus 1 is x plus 1 times the quotient is what? X squared plus 2x minus 1. Okay, so remember we were trying to solve what? We were trying to solve this equation, x cubed plus 3x squared plus x minus 1 equals to equals to 0. Now I can replace that by x plus 1 times x squared plus 2x minus 1. And so that means either x plus 1 is 0, right? Or x squared plus 2x minus 1 is 0. This tells me x is -1. Of course, we knew that already. And for the other one, the quadratic, what do I use? I could use the quadratic formula, for example, right? And if I use that, what's going to happen? X would be negative of the coefficient of x, which is -2, plus or minus the square of the coefficient of x, which is what? 4, minus 4 times the coefficient of x squared times the constant coefficient divided by 2 times the coefficient of x squared, right? Everybody's okay? And what do I have? Negative 2 plus or minus, it's what? 4 plus 4, right? Which is 8. So root of 8 divided by 2. And root of 8 is what? Root of 8 is 4 times 2, right? 8 is 4 times 2, so it will be 2 root 2, right? So I get negative 2 plus 2 root 2 divided by 2. And now I could say this is negative 1 plus, oh, I forgot plus or minus. Right? And we have all the three roots. Did that answer your question? Okay, so tomorrow I'll start with functions.